Today, I want to talk about something really interesting in calculus. The gradient of the tangent. The gradient of the tangent is equal to the gradient of the curve at a particular point. So, this is our today's lesson. The gradient of the tangent is equal to the gradient of the curve at a particular point. So, tangent is similar to other straight lines. However, tangent is very special because it only touches the curve at only one point. Tangent is a line that touches the curve at only one point. So when determining the equation of the tangent, so you're gonna need a point. It's similar to other straight lines. You need a point and the gradient. You're gonna need these two things: a point that gonna touch a curve and the tangent, and also a gradient of the tangent. These are the things that we're gonna need to determine the equation of the tangent. So let us put this information on our practice problems. Let us try this example. Let us try number 1. Let me first erase here. And be carefully not erase the question. Let me just So on number 1, find the equation of the tangent line to the curve y is equal to 2x cubed minus 3x squared plus 4x minus 6 at a point where x is equal to 2. So we need to find the point. So when we are talking about the point, we are talking, or let me attach the pen. We are talking about the paired coordinates, x paired with y. Right now, we do not have something like this, but we do have the x coordinates. So for the corresponding y coordinate, then we're gonna substitute x is equal to 2 into y. So the point that we're gonna get, it's going to be 2 into 2 cubed minus 3 into 2 squared plus 4x, and x is just 2 minus 6. And let me punch this on the calculator. 2 into 2 cubed minus 3 into 2 squared plus 4 into 2 minus 6. And then we're gonna get the point as our corresponding y value. It's going to be 6. Therefore, our point is going to be 2 paired with 6. Our x value is 6. Our x value is 2, and our corresponding y value is just 6. Now we do have a point. We need to find the gradient of the curve, the gradient of the tangent, by using the derivatives. So I think this is the enough space. To find the equation, to find the gradient of the tangent, remember earlier I've said that the gradient of the tangent is equal to the gradient of the curve, and curve does not have a specific value of the gradient, but however we can find the equation that's gonna represent the gradient of the curve. The first derivative of the function represents the gradient of the curve. So if you are going to differentiate this equation, we're going to get the gradient of the curve. So let us differentiate this equation. Y is equal to 2x cubed minus 3x squared plus 4x minus 6. The derivative of this function, we're going to get 3 times 2, we're going to get 6x squared. 2 times 3, we're going to get negative 6. And if you subtract 1 from 2, you're going to get 1. So the derivative of 4, we're simply going to get 4. The derivative of 4x simply 4x. 4, I mean. So this is our first derivative for this curve. Now, this derivative represents the gradient of the curve. So let me erase some stuff. Let me just erase here. So then that means the gradient of the tangent is equal to the first derivative of the function. So to find the value of the gradient of the tangent, we need to substitute this x coordinate to our first derivative of the function, and we're gonna get the gradient of the tangent. So it's going to be 6 into 2 squared minus 6 into 2 plus 4. So the value of the gradient of the tangent is going to be 6 into 2 squared minus 6 into 2 plus 4. And the value of the gradient of the tangent is going to be 16. So now we do have the gradient of the tangent and also a point. We can simply determine the equation of the tangent by using the standard forms of a straight line. The one that I'm going to use is this one. So I'm going to use the standard form. It's y minus y1 is equal to gradient of the tangent into x minus x1. So y1 is our y coordinates of this point is equal to gradient of the tangent. The gradient of the tangent is 16 x minus x1. x1 is our x coordinates of a point. So it's going to be 2. Transpose 6 to the other side of the equation, so our right hand side. So, and also distribute by 16 in this equation. So we're going to get 16x, 16 times 2, we're going to get negative 32 plus 6. Therefore, our final answer for the gradient of for the equation of the tangent is going to be 16x minus 32 minus 6. So we're gonna get 26, negative 26, negative 26.